In this video, we're going to talk about how to construct Taylor series when function is given. Taylor series generated by f at x equals a. Now, in some book, instead of a, they use c. But in this book, they use a. Let f be a function with derivatives of all orders throughout some open interval containing a. Then the Taylor series generated by f at x equals a is f of a plus f prime of a times quantity x minus a plus f double prime of a over 2 factorial times the quantity x minus a square and so forth. When you first see this formula, you might get overwhelmed, but just note that there's a pattern. For example, if it's first derivative, actually this is over 1 factorial. And look at the exponent, that's also 1. If it's second derivative, it's over 2 factorial, and the exponent over here will be 2. So whatever the derivative you take, just put n factorial as a denominator, and the exponent over here will be n. And we could write these terms as summation, using summation notation. Now, when Taylor series is generated by f at x equals 0, in other words, when a is 0, we call that Taylor series Maclaurin series. They want us to construct fourth order Taylor polynomial at x equals 0. Since x equals 0, we know that this Taylor polynomial will be Maclaurin series for the function f of x equals e to the x. I'm going to explain what fourth order means as we construct Taylor polynomial. Recall that the Taylor polynomial looks like this. And when they say fourth order, that means we need to go up. The n is 4. If they said third order, then you need to go up to this term right here, since n is 3. Now our function is f of x. So what we need to do is we need to find the fourth derivative of e to the x. So f of x is e to the x. F prime of x is also e to the x. F double prime of x is e to the x. F triple prime of x is e to the x. F to the fourth derivative of x is also e to the x. Now remember, we need to find f of a, f prime of a, and so forth. So our a is 0. So what is f of 0? F of 0 is e to the 0, which is 1. What about f prime of 0? That's e to the 0 as well. That's also 1. So f double prime of 0 is 1. F triple prime of 0 is 1. And f to the fourth derivative of 0 is also 1. So we have these values. Now all we got to do is to plug it in. So f of 0 is 1 plus f prime of 0 is also 1 times x minus 0 plus f double prime of 0 is 1, so it's 1 over 2 factorial times quantity x minus 0 square plus f triple prime of 0 is 1, so 1 over 3 factorial times the quantity x minus 0 to the third plus 1 over 4 factorial times the quantity x minus 0 to the fourth power. Now we're going to clean this up. So you get 1 plus x plus 1 over 2 x squared plus 1 over 6 x cubed plus 1 over 24 times x to the fourth. So this is the fourth order Taylor polynomial for e to the x. And we use p of 4 of x to represent that this is the fourth order of Taylor polynomial for a given function. Also, for instead of 2, 6, 24, you could just leave it as 2 factorial, 3 factorial, and 4 factorial. Now remember, our function was e to the x. And this was a Taylor, fourth order Taylor polynomial. Now let's see, we're going to use our calculator to approximate. Now remember, the center was 0, so we need to choose a number that is close to 0. So let's try to find e to the 0.1 and p of 0.1. And let's compare the values and see how close they are. So we have y1 as a fourth order Taylor polynomial for e to the x. And let's go to the home screen. So e to the 0.1 that is the actual value of e to the 0.1. Now, let's use our Taylor, fourth order Taylor polynomial for e to the x. So we need to choose y1 of 0.1. And see how close they are. The Taylor polynomial gives a good approximation of e to the x when x equals 0.1. Of course, if the value goes away from the center, which was 0, then our estimate will be way off. You should try that on your own. Now let's construct Taylor polynomial for sine of x when x equals 0. So the center is 0. So again, here is the Taylor polynomial, and we need to find the derivatives of sine x and plug in the values. So f of x equals sine x, f prime of x equals cosine x, f double prime of x equals negative sine x, f triple prime of x equals negative cosine of x, and then f to the fourth derivative of x equals sine x. And notice it's going to repeat. Let's just stop at the fourth derivative. So what is f of 0? Well, f of 0 is sine of 0, which is 0. What about f prime of 0? That's going to be cosine of 0, which is 1. What about f double prime of 0? That's going to be negative sine of 0, which is 0. And then f triple prime of 0 is negative 1. And then fourth derivative of 0 is 0. So the Taylor polynomial of sine x is f of 0, which is 0, plus f prime of 0, which is 1, times x minus plus f double prime of 0 is 0, and 0 times this whole thing will be 0. Well, let's write it down anyways. Plus f triple prime of 0 is negative 1, so negative 1 over 3 factorial times the quantity x minus 0 to the third, and then plus fourth derivative is 0, so 0 times the quantity x minus 0 to the fourth power over 4 factorial plus dot dot dot. So following this pattern, we could see that the sine x is x minus 1 over 3 factorial times x cubed plus 1 over 5 factorial x to the fifth minus 1 over 7 factorial times x to the 7 plus 1 over 9 factorial times x to the 9 minus and so forth. It says find the fourth order Taylor polynomial for f of x equals natural log of x at x equals 1. So now our a is not 0, it's 1. So we have our Taylor series up to when n equals 4. Now we got to find the fourth derivative of natural log of x. So f of x is natural log of x. And what is f prime of x? That's 1 over x. And what is f double prime of x? That's negative 1 over x squared, which is the same thing as negative x to the negative 2. What about the third derivative? That's going to be 2 times x to the negative 3. What about the fourth derivative? That's going to be negative 6x to the negative 4. So now what is f of 1? Now you got to find f of 1 because our a is 1 now. Natural log of 1 is 0. What about f prime of 1? F prime of 1 is 1 over 1, which is 1. F double prime of 1 is negative 1. What about f triple prime of 1? That's going to be 2 over 1, which is 2. And then fourth derivative of 1 is negative 6. So now the fourth order polynomial, Taylor polynomial will be, let's plug it in, f of 1. F of 1 is 0 plus f prime of 1, which is 1 times the quantity x minus 1, plus f double prime of 1 is negative 1, so negative 1 over 2 factorial times the quantity x minus 1 square plus f triple prime of 1 is 2. So it's going to be 2 over 3 factorial times the quantity x minus 1 to the third plus f to the fourth derivative of 1 is going to be negative 6 over 4 factorial times the quantity x minus 1 to the fourth power. So let's clean this up. You get fourth order Taylor polynomial will be quantity x minus 1, and then it's going to be negative 1 over 2 quantity x minus 1 square, and this is going to be 2 over 6, which is positive 1 over 3 quantity x minus 1 cube. And this is going to be negative 6 over 24, which is negative 1 over 4 quantity x minus 1 to the fourth power. Now, our f of x was natural log of x when the center is at 1. So if you want to estimate natural log of x using this Taylor polynomial, you need to choose a number that is somewhere near x equals 1. So for example, like x equals 1.2. That way, this polynomial would give you a good approximation of natural log of 1.2, since the center is at x equals 1. So I want you to find f of 1.2 using your calculator and find p of 4 of 1.2 and see how close they are.